Hey there. My name is Will Hart, and I'm the VP of Product here at Quilter. And I'm really excited to share that Quilter now supports automatic detection and routing of differential pairs. So to demonstrate this, I am at my homepage of my Quilter application, and I'm going to open up a draft job that I uploaded just before this, which is for the Raspberry Pi Pico V1. So you can see here I've got the PCB doc and schematic that I uploaded previously in Altium, and this is a preview of my board file with parts replaced, but most of the components here on the right for Quilter to place and route. So I'm going to press continue, and what I'm going to see here is a brand new constraints page, which has been retitled Circuit Comprehension. So the purpose of circuit comprehension is for Quilter to build a complete understanding of all the physics concerns that are in your design so that it can do the right things when it comes to actually generating layouts. And so in this case, one of those categories of physics concerns is a differential pair. And so Quilter has looked at my design files and it's automatically detected two differential pairs in my design. You can see them. These are paired nets that have a common string at the beginning and then differ by a set of suffixes that are common in annotating differential pairs, P and N or plus minus. You can see a full list of how we detect differential pairs over here. So it's detected that there are two of them. And now what I have the opportunity to do is to go in and to indicate the target differential impedance that I want for this pair. So I can choose currently between 100 ohm and 85 ohm differential impedance with corresponding single-ended impedance requirements. And I can also set the carrier frequency for the signal so that Quilter knows how to complete the calculations necessary to optimize the trace width and the spacing for the signals in this pair for each individual layer stack or stack up that it explores. So if I press continue, this is the page where I can review and submit my job. Instead of submitting it now, I'm going to jump to the results from a prior run. And this is what I see. Right out of the gate, I can see that Quilter's routed my differential pair successfully, right? So I've got my USB connector up here at the top, and it's routing one segment of the pair down to a set of terminating passives. And then that signal continues on here to my RP2040 microcontroller. So I can see that Quilter understood the instruction around my differential pair and has routed it accordingly. I can also notice down here that there's now a specified fabricator associated with each candidate that Quilter explores. And the reason for that is when you're building impedance-controlled signals, you need to understand the material properties of the stack-up that you're working with in order to ensure that the single-ended or differential impedance of the resulting traces is correct. And so here, this is a 4-layer, 1-ounce external copper, 1.6 millimeter stack-up that was defined in partnership with Macrofab that's been used to create this particular design. If I want to, let's say I want to work with, I'm planning to fabricate this with Macrofab, and I want to look at 4-layer designs because 6 layers is a little more expensive, and I want to make sure the trace clearances aren't too small, so let's say a minimum of 5 mil trace width and spacing. So that gives me 3 100% routed candidates, so I can take a look at this one, I can take a look at candidate 1, and let's say I like candidate 52. So again, at this point, if I want to learn more about the particular stack-up, I can click through here, and I can see the information about the impedance profiles and the particular material properties, thicknesses, and even things like the dielectric constant that are relevant to this particular stack-up. But of course, I can also download this design and inspect it directly. So I'm going to click that. This is the same candidate that I just downloaded. And when I go to inspect it in Altium, I see I've got my design here. I see my differential pair routed successfully. And I can also go and inspect the stack-up and see that the specific stack-up for the candidate that I downloaded has been exported to my stack-up manager here in Altium that I can reference when I take this board to fabrication. Finally, if I want to work with Quilter to fabricate this board, I can request fabrication via our Fab for Free program and ultimately get this board built, saving me a bunch of time routing and exploring different candidates with different impedance requirements and differential pairs. That's the feature. We're excited to see what you think of it.